Hi again, and we are continuing talking about the yurt, its origin, history, design, performances, and etc. And in this particular video, we will be talking about its design and performance and how it is perfectly suited for the nomadic lifestyle and the natural environment, natural landscapes, and climate conditions that it was used in. So if we look at this image, it shows how the E is element proof in its design. For example, the first image shows how E is earthquake resistant. Now, see the arrows. One arrow shows one arrow is horizontal, one is vertical. These represent the two most common types of earthquake. As we know, earthquakes could be uh, vertical when the earth is shaking like this, or it could be horizontal when the earth is moving like this. And uh, this one is even less. The vertical movement is even less dangerous than the horizontal, because the horizontal causes the most damage to the cities, to the buildings, while vertical kind of like it doesn't move. Uh, it doesn't change the position of the building sitting on top of it. It's just going up and down. While when it's horizontal, it means the foundation is moving in relationship to the roof and to the walls, and it creates this kind of movement, and so buildings just uh, collapse. Now, for the most part, these both types of earthquake do not concern yurts at all. First of all, yurt is a very light structure. As we already know, it's wooden frame with felt cover. So uh, it's very light, and because of that, the uh, it doesn't experience such great gravitational forces during earthquake. So it's kind of like no matter what movement, uh, horizontal or vertical, it's gonna just move along. It's not gonna do anything. There is no inertia. It's just gonna move along with the earth crust. So that's one thing. Another thing is yurt is all flexible. The skeleton it's not rigid. It's tied with ropes. So the wall lattices can move. Everything is designed in a way that pretty much the entire structure or skeleton of the yurt, the frame, is completely shock absorbent. So no matter how violent the earthquake is, it's going to absorb all of it easily. And finally, it's covered with the felt dressing and tied with the ropes. So it creates this kind of containing envelope, if you will, that wouldn't let any parts go anywhere. So it's going to stay together in one piece. It might shake, it might move, but it's going to stay in one piece. And all in all, even if for whatever reason it collapses, what's going to happen? Nothing. It's so light. It's not like a tons of bricks or a concrete slab falling on your head. It's just wooden structure. Most likely, even if it collapses, people would survive. So I consider it completely and utterly earthquake proof. Now, On the second diagram shows how yurt is well suited to meet the challenges of seasonal temperatures. So it's the same yurt. I kind of divided the diagram in two parts, one showing cold climate or cold season, and another one showing hot. So as you can see, the cold part, when you completely seal off the yurt and you get this envelope of felt cover on the outside, then we add as many rugs on the inside. It creates this sandwich of layers that kind of traps air, creates these air pockets everywhere, and the felt itself is fairly it's pretty good isolating material. I don't know if there are probably there is a way to measure its R ratings and etc. But it's pretty good because it's been used for thousands of years. When it's thick, when it's very dense, it provides a lot of thermal isolation. There are no cold bridges because first of all, it's completely sealed off on the outside. Second of all, there are no metal or concrete parts. It's all wood. Wood is not. Wood is a very good isolation material by itself. It doesn't get cold. It doesn't create a temperature bridge. So, you know, all in all, very good isolation, very good building envelope on a yurt, and you know. As they say, you can warm it from the inside with one candle. Of course, maybe not one candle, but a small fire in the middle of it would create enough to sort of uh, dissipate the warmth, the warm air inside of it. And because yurt is round and semi-spherical, there are no corners with where the stale air would gather and stay. So there is circulation, and even the conduction and radiation would be very efficient inside of the yurt. So literally, a small fire would be more efficient inside of a yurt than it would be inside of a square house. So it's really, really well designed for cold temperatures. And in summer, same yurt could be, because yurt is a transformer, you can transform it from completely sealed off dwelling to semi-open. You can open doors. You can roll up the keys yesik, the felt door. You can open the skylight, the shanrak. You can even lift and roll up the sides of the fell on the kerge, and you know you have entire uh, collection of methods of keeping it cool. And you know, I've stayed in a yurt in summer. Really, it's always much cooler if you take these measures that I just described. It's always cooler on the inside of the yurt than there is on the outside. So it's really efficient. I can testify. Now, how does yurt stack up against percipitation? Because obviously you live in the open steppe. You are subject to all kind of harsh environmental precipitations and influences. You get rain, you get snow, you get wet snow, you get icy snow, you get hail. So how does it stack up against them? Well, as you can see, Uh, the design of the yurt is very clever. Every piece of felt is designed in such a way that it always overlaps one on top of another, and it creates these dripping points, as we call them in architecture, so that even if the felt gets soaking wet, uh, because of the gravity, the water would be slowly draining towards the edges and then dripping on the ground, but not inside the yurt. Inside of the yurt, if you touch a wall, of course, it might get wet. But if you don't touch it, it's probably just gonna uh, roll down and just go to the ground. And I've seen that uh, on a rainy day. If you walk around the yurt, you would see a little the dripping the drops falling from the roof felt piece. They form this kind of little trench in the ground. They kind of, because they're dripping constantly, they create this shallow little trench around it, and you can clearly see how it works. And it's all intentional. It's all by design. Same with other elements. So I would say again, uh, it's really well designed to withstand precipitation. And finally, talking about wind loads, as you can see, shape of a yurt is fairly, if not perfectly, aerodynamic. And it's kind of like, if you flip over a cooking wok uh, or cooking pot of semi-spherical shape, and you try blow it away with a wind, nothing would happen, because the shape, first of all, it works in two ways. First of all, it kind of uh, allows wind to break and kind of go around a yurt, and just, without even, it doesn't create a seal effect. It's just all around, and the wind just goes around and goes away. And another one, because of the shape of a dome, uh, part of the wind force would be pressing a yurt against the ground, so creating this even more stable, stabilizing effect. So in other words, it acts as a windbreaker, and at the same time, it creates this negative pressure that's kind of pressing it against the ground. And so it can withstand enormous wind loads. Of course, if it's not properly assembled, if it's not properly oriented, uh, there is a risk of wind getting underneath layer of a felt and then ripping it apart, and then it can become catastrophic. But that's something that comes with the experience. The nomads who would live in these conditions obviously knew what they were doing, so uh, you know after a while they would learn to do it properly and do it, year after year, decades after decades, century after century, millennia after millennia, and it worked. So we know that it worked. Now, couple more words about Y's design versatility. I already mentioned how it's good to withstand temperatures, but let's talk a little bit about ventilation, um, because the skeleton of a yurt, if you will, is all uh, open. It's just, it's a complete open lattice and poles and etc. air can penetrate freely through a frame. Now, when we cover it with felt, uh, in summertime we usually put underneath of felt, we usually wrap it with a layer of straw mat. And what it does, uh, it creates an additional effect. In some areas, if there is no wind or precipitation, they might not even use felt wall cover. They only use these straw mats to wrap around an entire perimeter. And that's enough in summertime because it provides enough protection against elements, but at the same time it allows for air movement. And like I said, we can always um, lift bottom edge of a felt, wrap it up, secure it, and it's kind of like opening a window. It would allow air to breathe. Oh, and also we can open doors too, so that we let as much air in as we need. And why would it go inside if supposedly there is a stale air outside? Because we have this shanrak, the skylight, which also simultaneously is a vent shaft, vent window, and also smoke window. So it's three purposes. Oh, and not to mention the construction purpose of holding the dome together. So it's multi-purpose piece on top of a yurt that is both structural and functional. And what it does in terms of when talking about ventilation, it creates this updraft. It creates this chimney effect when it's pulling the air from underneath, cooler air, and then warmer air rises and it creates this circulation. And that is enough that on a hot day, if you open if you open the right side of a yurt, if you lift felt on the correct side of the yurt, you really feel this air movement, and it's cooling you down. So it's really pleasant. And because we have so many layers, as shown on the right, we can, on another hand, when the weather is cold, we can just keep wrapping it and wrapping it and wrapping it until it's cold enough for our purposes. So that's kind of main things about your design and performance, because yurt is a fairly simple concept. It's a wooden frame. It's covered by pieces of felt, and clad with rugs on the inside, and that's it. But how many possibilities, what kind of versatility at the same time it offers you by using these very simple techniques, very low tech, not not labor intensive, but it offers so much in terms of creating comfortable living conditions. It's like a transformer. You can add parts, you can subtract parts, you can design it and use it the way you want, and it just matches all of your needs, living in the open steppes. Now, another interesting feature of a yurt is how we can combine them together, because a frame of a yurt is basically like a Lego constructor. We can put parts together, and we can put two yurts together, and we do it by removing one of the carrier sections of two yurts, which creates opening, and then we add these two yurts with their openings facing each other, and we secure them like this, and that creates a double yurt. And the way it was used, as I was reading, is that, for example, one yurt would be used as bedroom, family bedroom, another one could be a guest room or living room, and etc. And technically there is no limits to how many yurts you can join. It's all up to your imagination. So that's yet another very interesting feature of a yurt. So all around it's just ingenious, it's clever, it's well engineered, well designed, and it performs really, really well for the given conditions and nomadic lifestyle. So that's kind of a quick overview of design and performance and versatility. This is it for this section. We are moving to the next one, and I hope I will see you soon again. Thank you.